in 3D, if we try to proceed ahead with planes, we must have this next idea, that is angle between two planes. Now, let us firstly consider two planes, try to figure them out. This is one of the possible plane. And we are considering another plane, and let us first mark the other plane. This is another plane. I can mark the outward normal direction of the second plane like this one. And we can consider the outward normal direction ratio for the first planes as this one. Okay. So if we try to consider the angle between two planes, it will be same as the angle between these two direction vectors, which are outward normal directions. So angle between two planes is considerable as the angle between their outward normals. Is that okay with everyone? So like earlier, we can definitely consider if angle between the planes is theta, then the same theta is also angle between the outward normal vectors n1 and n2. So let theta be the angle between two planes. Then cos theta must be same as n1 unit vector dot with n2 unit vector. Is that okay with everyone?
Yes, sir.
So the condition of perpendicularity must be n1 cap dot n2 cap is equals to 0, and the condition of parallelity will be n1 as some constant time of n2. Is that okay with everyone? Sorry, not the cap ones. Please mark the correction. It's n1 vector is same directional as n2 vector. So n1 vector is some lambda times of n2 vector. So if we try to mark these things in Cartesian form, we can think of, let the planes are given by a1x plus b1y plus c1z plus d1 equals to 0, and a2x plus b2y plus c2z plus d2 is equals to 0. So definitely in comparison to the earlier theory, I can mark n1 vector as a1 I cap, a2 I cap, a3 I cap, a4 I cap, a5 I cap, a6 I cap, a7 I cap, a8 I cap, a9 I cap, a10 I cap, a11 I cap, a12 I cap, a13 I cap, a14 I cap, a15 I cap, a16 I cap, a17 I cap, a18 I cap, a19 I cap, a20 I cap, a21 I cap, a22 I cap, a23 I cap, a24 I cap, a25 I cap, a26 I cap, a27 I cap, a28 I cap, a29 I cap, a30 I cap, a31 I cap, a32 I cap, a33 I cap, a34 I cap, a35 I cap, a36 I cap, a37 I cap, a38 I cap, a39 I cap, a40 I cap, a41 I cap, a42 I cap, a43 I cap, a44 I cap, a45 I cap, a46 I cap, a47 I cap, a48 I cap, a49 I cap, a50 I cap, a51 I cap, a52 I cap, a53 I cap, a54 I cap, a55 I cap, a56 I cap, a57 I cap, a58 I cap, a59 I cap, a60 I cap, a61 I cap, a62 I cap, a63 I cap, a64 I cap, a65 plus B1 j cap plus C1 k cap, and N2 vector has to be in that comparison A2 I cap plus B2 j cap plus C2 k cap. As already in the first session with planes, we have discussed about the fact that the coefficient of x, y, and z in that order respectively gives you the outward normal direction ratio. So that means if the angle between the planes is cos theta, then this cos theta is nothing but A1, A2 plus B1, B2 plus C1, C2 divided by root over A1 square plus B1 square plus C1 square, and another factor of the denominator is A2 square plus B2 square plus C2 square. The condition of perpendicularity, the numerator has to be 0. A1, A2 plus B1, B2 plus C1, C2 is equals to 0. Whereas for parallel planes, we must have the proportionality of the component. A1 by A2 is equals to B1 by B2 is equals to C1 by C2. So all of you can identify that these are the similar conditions that we have found in the part that is angle between two lines. As such, angle between two planes been delivered by actually the angle between two lines or two linear direction which are the outward normals. The next idea that we will address is intersection of a plane with a line. So let us consider, let the given line is x minus x1 by a1 is equals to y minus y1 by b1 is equals to z minus z1 by c1. In Cartesian form, in vectorial form, we can also mark it as r minus p1 is equals to lambda d1 vector. So as per the comparison, we are considering P1 position vector as x1 I cap plus y1 j cap plus z1 k cap, and direction vector d1 is considered as a1 I cap plus b1 j cap plus c1 k cap. And the plane say been given by ax plus by plus cz plus d is equals to 0. Or we can consider this as some r minus p dot n is equals to 0. So definitely over n is a I cap plus b j cap plus c k cap. Okay. Now to determine the intersection of the plane with the line, if we try to have a figure corresponding to this, this is the plane we are addressing, and this is the line, and say the intersection is we are considering the intersection point is this one. So our target is to determine this point, what I marked as, we already have used P, so let us mark that as some Q. So if Q is the common point, so it is lying on the line as well as on the plane. So the procedure of determination will be, we can consider a general point on the line. So mark this as any point on the line can be taken as A1 lambda plus x1. I'm writing that on the next line. A1 lambda plus x1, comma b1 lambda plus y1, comma c1 lambda plus z1. Now, if this point common with plane, then it must satisfy the equation of the plane. So we will have A into A1 lambda plus x1 plus B into B1 lambda plus y1 plus C into C1 lambda plus Z1 plus D is equals to 0. Now the only unknown here is lambda, which can be determined as lambda is equals to minus of ax1 plus by1 plus cz1 plus d divided by aa1 plus bb1 plus cc1. Now, using this value of lambda, we can complete the coordinate of the common point. So as per the methodology is concerned, whenever we need to address point of intersection for a line and a plane, we will simply assume a general point on the plane. Sorry, we will assume a general point on the line and we will satisfy it to be on the plane. That will give us their common point. The next idea is angle between the line and the plane. So angle between a line and a plane. So already with the line, we do have a direction. Let us consider the outward normal direction ratio of this plane is that vector n we have marked, and this line already in the direction of vector d, or sorry, vector d1 as we have assumed. So if this angle is appearing as theta, so the angle between the plane and the line, it has to be complementary part of theta?
Yes, sir.
Okay. So we can think of cos pi by 2 minus theta sorry, let us go for cos theta itself. Okay, cos theta is appearing as n cap dot d1 cap, and from there if I get to theta, we will get to pi by 2 minus theta is the angle. Okay. So we will simply derive cos theta because the directions we have is n vector and d1 vector, and we can have the angle between the outward normal and the direction of the plane by the dot product of corresponding unit vectors as cos theta. From there, as soon as you get determination of theta, so pi by 2 minus theta is the angle, that is, we can mark required angle is pi by 2 minus cos inverse of n cap dot d1 cap. So this will be the angle between the straight line and the plane. So if I try to write in Cartesian form, we will have sine, sorry, cos theta still to be determined in this form, earlier form. So we can consider this cos theta, which is as per the demarcation, is going to be A1 plus B1 plus C1 divided by root over A square plus B square plus C square into root over A1 square plus B1 square plus C1 square. So from there we can determine theta in Cartesian form, and again pi by 2 minus cos inverse, this value is going to be the required angle. But due to that, there will be a bit of change in condition of perpendicularity. So if the line is perpendicular to the plane, then n vector and d1 vector must be parallel, because if the line perpendicular to the plane, then it is parallel to the outward normal, and hence we will get the condition as A by A1 is equals to B by B1 is equals to C by C1. But if we get the line parallel to the plane, or it might be possible the line is contained by the plane, in both occasions we'll have n vector and d1 vector perpendicular to each other, hence their dot product will be 0. That is, as per Cartesian consideration, will give us A1 plus B1 plus C1 is equals to 0. And you can identify when the line and this plane is parallel, the point of intersection determination will not be possible, because the determination of lambda that we have marked earlier, having a denominator same as A1, BB1, CC1, So it will not be possible to determine by the earlier process then. Because if the line is parallel to the plane, then there is no point common. Or if the line is contained by the plane, then there are infinite points common. Even all the points lying on the line are common with the plane.
স্যার এটা আরেকবার বলবেন
কোন পার্টটা বলো তো?
তো ওই প্যারালাল যেটা a1 a1 plus b1 equals 0 এটা
Yes, just consider a plane. Say this is a plane and a line which is parallel to that. So I am considering the outward normal direction for the plane is this direction. Now a line which is parallel to the plane.
ও বুঝে গেছি হ্যাঁ স্যার ঠিক আছে
Okay. So this is your d1 vector direction and this was your n vector. So when the line is parallel to the plane, then it is perpendicular to its outward normal. And hence we are going to get this condition. Okay, this will also be true when the line you are considering is contained by the plane. The next idea that we will target is image of a plane, image of a point with respect to a given plane. So let us firstly try to figure this out. Say we are given with this plane. Okay, if I try to have, just a moment. If we try to have reflection of this point, so this is a point been given as capital A, I need to reflect this on this plane. So what should we do? So we have firstly considered to have the reflection we just need to have the line joining the object with the image. And the midpoint has to be there on the plane itself. Then only I can have this A dash. So if I can have M, which is foot of the perpendicular drawn from A on the plane, we can also determine the image A dash. So in that direction, we have firstly considered the coordinate of A is given. So let us write that. Let A been given as x1, y1, z1, and the plane is ax plus by plus cz plus d is equals to 0. So we will firstly construct the perpendicular line of the plane through A given by, or not given by, we can construct this as, we know the outward normal direction ratio, that's A, B, C, and we do have a point, so we can go for x minus x1 by A is equals to y minus y1 by B is equals to z minus z1 by C. Okay. Now we will determine the point of intersection for the given plane and the constructed line. We can perform so by the earlier theory. We have just now gone through that idea, that how to decide the point of intersection for a plane and a line. Say M. So as soon as we can determine M, the image or the required image of A, say A dash, must divide AM in the ratio 2:1 externally. Is the way clear to everyone?
Yes, sir.
This also has given us the way to get to minimum distance of a point from a plane. This AM is the minimum distance of the point A from the plane. Whereas we can also mark that, if we try to consider this as the next part, mark the idea as minimum distance of a point from a given plane. So if I consider A is that point and we are considering, okay, let us have another diagram to have the alternate process like the earlier diagram already justifying you. If you can describe, if you can determine up to the coordinates of M, we can have AM as the minimum distance. Or in general, if I consider this is the plane and this is outward normal direction vector, say N vector, and we are having in terms of the plane, which is given as r minus p dot n is 0. So that means on the plane itself, I do have a reference point, say P, and our targeted point is some point A with position vector, we are considering small a. And the reference point P, say this is for point capital P, the position vector is small p. So we can also think of having a possible measurement in the form of have the vector AP, and if I project AP along n vector, then definitely it will be the minimum distance. So projection length of AP along n cap must be the minimum distance. Is that clear to all? So
Yes, sir.
minimum distance, if I mark that as d min, it's nothing but AP dot n cap within modulus as we are considering minimum distance. So if I go Cartesian and consider the representation of the plane as ax, or say a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equals to 0. Okay, and we are considering the point A when given in terms of Cartesian coordinate alpha, beta, gamma. So as per this description, we will have minimum distance modulus of a into alpha minus x1 plus b into beta minus y1 plus c into gamma minus z1 divided by root over a square plus b square plus c square. That is, simply we will substitute the given coordinate for the point A on the equation of the plane, and the absolute value for the substituted expression divided by the magnitude of outward normal direction vector will give us the minimum distance. Okay. Next idea to be considered is line of intersection for two planes. If we try to figure that out, say this is a considered plane and another plane is this one. So what we will get as the line of intersection this is our target. Okay. Now the first identification that we can have that this line is definitely perpendicular to the outward normal for the plane. This must be right angle, as the red line is contained by the second plane as well as it is contained by the first plane. So if I consider the outward normal direction for the first plane, this is also perpendicular. So the direction of the red line, which is perpendicular to both outward normal vectors n1 and n2, if I consider my planes as r minus p1 dot n1 is equals to 0 and r minus p2 dot n2 is equals to 0, then direction of the line of intersection, that is common line of both the planes, must be n1 cross n2. Any problem up to that? Have you all followed? Now to complete the line, along with direction, we need at least one position vector attained by the line. Now here comes the procedure. Rest part I'm writing in Cartesian form. Say the equation of the planes are given by a1x plus b1y plus c1z plus d1 is equals to 0 and a2x plus b2y plus c2z plus d2 is equals to 0, and hence direction vector of the line must be, we can determine it by the cross product. That's I cap, j cap, k cap, first row, then a1, b1, c1, the outward normal direction ratio for the first plane, and then a2, b2, c2, the outward normal direction ratio for the second plane. Okay. And once you are done with that, a line is going to appear with its direction already determined. Now a line has infinite points. If you fix the value of any one of the three variables, accordingly we can determine the value of the other two variables. So ahead of that, say we are marking this as vector D. So ahead of that, to determine a point on the common line, which is the line of intersection. Let us firstly mark this equation with two numbers, 1 and 2. Substitute suitable value for any one of the three variables in 1 as well as 2. Now, as soon as you do that, what will happen? Like in relation 1 as well as in relation 2, we had three variables each. You have decided a variable and you have substituted a suitable value for that. As such, if your line's direction is not parallel to any of the reference line or reference plane, means if it is not parallel to any coordinate axis or any of the coordinate plane, in that case, we can expect x, y, and z dependently can vary from minus infinite to plus infinite. Like each of x component, y component, and z component for points situated on this line will vary from minus infinite to plus infinite. And if you decide the value of any one component, the other two components will appear to us dependently. So accordingly, what we are doing, we are substituting a suitable value for any one of the three variables. Now say I am putting z is equals to 0 on both this relation. That will transform your relation 1 and relation 2 into two equations of two unknowns, x and y. We can solve that. Solving them, what value of x and y we can get, these are just corresponding values to the substituted 0 for z. So the solution we have got x is equals to alpha 1 and y is equals to beta 1. So that means the line which is common to both the planes must pass through alpha 1 comma beta 1 comma 0. And once we are decided with a common point, we can complete our line. Okay. Has everyone followed the example? So this will reduce one and two into two equations in two unknowns. Solving them, we can get corresponding values and hence the solution, the found solution and the substituted data and the substituted value will form the coordinate of a point on the required line. Okay. So we are already decided with the direction vector D, say the coordinate you are forming. Okay. Say the coordinate formed is alpha 1, beta 1, gamma 1. So required line will be x minus alpha 1, or let's just not mark this in this way. So this alpha 1, beta 1, gamma 1, this one been considered as a position vector. Say already have used any vector. So let this is some q position vector. So required line will be r minus q is equals to lambda d vector. Is that okay with everyone? Next mark, if a plane pass through the line of intersection of two given planes, say P1 equals to 0 and P2 equals to 0, then it can be, or it can always be represented as P1 plus lambda P2 equals to 0. So it is quite similar to the considered of line in two dimension. In two-dimensional geometry, you have gone through this information that if we are given with two lines, L1 equals to 0 and L2 equals to 0, then any line passing through their point of intersection can be marked with L1 plus lambda L2 equals to 0 by the idea of family of concurrent line. Over here in 3D, we are considering the family of concurrent planes. So if I get any plane which is been described in reference of two given planes who are intersecting with each other along a line, we may or may not be given with that line, but if we are given with the equation of the planes, So simply a constant combination of the equations of the planes can give you the equation of this plane. Okay. So a family of concurrent plane where the line of concurrency is common line of the planes P1 equals to 0 and P2 equals to 0 can be represented as P1 plus lambda P2 equals to 0. You can have a corresponding diagram like, say, this is a plane. We are considering another. So this is another plane. So what is their line of intersection if I consider other planes through them? It can be identified so that means this green plane, which is passing through the line of intersection of the blue plane and the pink plane, this was the line of intersection, which is common in all the planes. So if this is your P1 equals to 0, this blue plane, and the pink one is your P2 is equals to 0, then the green plane that can definitely be marked as P1 plus lambda P2 is equals to 0. Is the idea clear to everyone? Next, consider angle bisectors of two planes. If you consider two planes are given by A1x plus B1y plus C1z plus D1 equals to 0 and A2x plus B2y plus C2z plus D2 is equals to 0. Like in the earlier diagram, you can consider the blue plane and the green plane. The pink plane, which will be appearing as the angle bisector, it is definitely accumulation of all the points which are maintaining equal distances from both the arms. And as per the last idea, we can now have distances of points measured from a plane. So that means for angle bisectors, this will contain points which are equidistant from both the plane. Whereas for any point, distance from the first plane can be marked as modulus of A1x plus B1y plus C1z plus D1 divided by root over a1 square plus b1 square plus c1 square, whereas distance from the second plane will be a2x plus b2y plus c2z plus d2 divided by root over a2 square plus b2 square plus c2 square. Can you follow this distances? Now for angle bisector, both these distances has to be equal. Then only the point can be on the angle bisector. So this is combined representation for the angle bisector planes. Okay. And if you withdraw the modulus from either side, we'll have a plus association or a plus correspondence or a minus correspondence between the two sides that will take us to the individual planes. Definitely, we already know condition of perpendicularity for two planes. So if the planes are not perpendicular, then we can have even acute bisector plane or obtuse bisector plane. Okay. And how to decide on that? So for that, mark for non-perpendicular planes, A1, A2 plus B1, B2 plus C1, C2 is non-zero. Okay. So we will represent the planes such that D1, D2 greater than 0. That is, they are of same sign. Then from the combined representation, following the same sign as the value of A1, A2 plus B1, B2 plus C1, C2, we must get obtuse bisector.
Sir, D1, D2 greater than 0 tower पे जाके.
That means you need to represent the planes such that the constant term of their representation carrying same sign. Either both the constant term are appearing positive or both the constant terms are appearing negative. The sign of the constant term in the representation of the plane has to be same. So if you are ensuring that at that point, you will get A1, A2 plus B1, B2 plus C1, C2 as a value carrying some sign, as it cannot be signless or zero. Only perpendicular lines can have that value 0. So whatever non-zero value it is generating, it is carrying some sign, maybe positive, maybe negative. If you follow the same sign as that value from the combined representation, then we are going to get the equation for obtuse bisector. Okay, here combined representation means after removal of the modulus, what plus or minus two choices you have. So out of plus or minus choice, which one to follow to get to obtuse bisector will be decided by the value found for A1, A2 plus B1, B2 plus C1, C2. Next, we will consider some special information. Now, what are the special information? Say, we are given with a plane and we have been given with a line say the line intersecting the plane at this green point. And we are given with another point. The coordinate of this point is given. Okay. Say the name of the point is A. The plane is given by P is equals to 0 and the line is given by L is equals, sorry, the line is given by L. Okay. As the equation of line is a combination of three parts or two different equations, so I'm just considering that to be L. So whatever is, these three informations are given: coordinate of A, equation of L, and equation of the plane in the form P is equals to 0. On that basis, let our requirement is two things. Firstly, distance of the plane from A measured parallel to the line. Okay. And the second type of requirement can be distance of the line L from given point A measured parallel to the plane. This can be two types of requirement. Let us consider the first. So, if I, yes, is this far sufficient?
Oh, okay.
So, as per the first requirement, we need to have this measurement. This is distance of the plane from A when it is measured parallel to the line. So how to get to that? We can think of, for the first variation, we will frame a line with same direction as L and through the point A. We can have that. Is it clear to everyone? As
Yes,
L
sir.
is given, so we know its direction. So using the direction of L and coordinate of A, I can construct another line. Okay, as drawn, the violet line in the diagram. Step 2, have intersection point of the constructed line and the plane. Say Q. So what do we want as per first query? Can anyone mark from the diagram? What do we want?
AQ.
AQ.
Take.
So measure distance between A and Q. And that's our requirement. So has everyone followed what we required and how we have determined so? The next part, the second requirement, distance of the line L from A when being measured parallel to the plane. So if we try to mark, it is such a distance. But look carefully, if I join the green point with Q, isn't it the same distance?
Yes, sir.
Sir,
As
green
it
point
is
of an
forming,
intersection of L and P.
yes, the green point is the intersection point of given line L and given plane P is equals to 0. So if we consider the two lines and the two orange lines we have drawn, red line, the violet line AQ, and the two orange lines I have marked, they are framing up a parallelogram. We require this measurement. Instead, we can have the other end measurement, the opposite side measurement for the parallelogram. Okay, let us mark this point as S. Okay, so in connection with the second requirement, let us write step 1. Determine the point of intersection for given line L and given plane P is equals to 0. Step 2, determine Q as per last procedure. So in the last approach, we have already decided Q, which is combination of two steps. We need to frame a line with same direction as L through A and having intersection point of the constructed line with the given plane. That was Q. Okay. So if I mark the first point, say S, so let us mark this point as S. So determine the point of intersection S for given line L and given plane P is equals to 0. Determine Q as per the last procedure. And as we have already decided from the diagram itself, SQ will give us the answer for the second requirement. So measure distance between S and Q. Have you all followed these procedures? These are two such special requirements. Firstly, construct them from the diagram and accordingly decide the strategies. It is simple calculation to follow up the strategies.